All right, so we are here to talk to you guys about line SQL injection with the tool that we wrote called BBQ SQL. My name is Scott. This is Ben.
Backwards.
Yeah, backwards.
Backwards. I'm Scott. This is Ben. So kind of some of the, basically we just kind of want to start with some prerequisites because we did a similar talk to DEFCON. We've had some new features. We just don't want to waste anybody's time. So if you're attending this talk, we just assume that you know what SQL injection is and how to exploit it. So you're coming from an AppSec background, maybe you've used some black boxes and stuff. You're familiar with the scripting language such as Python or Ruby or something like that, and you want to bring stuff. So if those things all sound like you, you're in the right place. So who are we?
I'm Ben Toews. I'm a security consultant and researcher at NeoHapsys. We focus there primarily on application and network penetration testing.
And I'm Scott Behrens, senior security consultant and researcher, the same kind of stuff that Ben does. So, I guess we'll start with why are we here? Because SQL injection is something that, as being AppSec guys, we're familiar with. We see it all the time. Basically, what we're presenting is a new dog with an old trick, right? Where it exploits blind SQL injection. But the big difference is that it's fast, easy, and it gets those hard to reach spots. And we'll go into a little bit of detail on exactly why that's the case. So there are a lot of excellent tools out there, and by lots I mean there are tons. SQL Map is totally kick-ass. All these tools have great features, but I'm sure some of you guys probably run into this, like where you're running a tool, you've identified something, you know it's exploitable. You go to run the tool and it doesn't work. And then you're like, okay, well I can figure this out. And you end up messing with it for like an hour and you're like, okay, I actually can't get SQL Map to do the data exfiltration, right? So what do you end up doing? Well, maybe you pop open Python and you start writing a script, right? And then you're testing the script, and you're debugging the script, and you're testing, and you're debugging. You end up spending all this time to do one exploit, right? Maybe because there's some nuance or something that makes it so that these other tools don't work. And Ben and I were kind of thinking of like, what if we could kind of take out the part that takes the most time when you have to write your own script and kind of come up with a framework that'll help us automate some of the really pain in the ass stuff that you have to do when you can't get things to work. That's where we decided to combine really tasty food, like barbecue, with awesome flying database tables, because that's what a database looks like. We end up with BBQ SQL. So.
Alrighty, so as we've already kind of alluded to, BBQ SQL is a tool for exploiting blind SQL injection. When we say hard to reach spots, we're talking about these instances that Scott was just talking about where everything else just kind of fails and you need something that works, you need something that's fast. As opposed to tools like SQL Map, this is not fully automatic. This is not going to find the vuln for you. You need to know what you're doing. But once you have that, there's an incredible versatility. So when you have these really weird situations, and we'll give some examples of weird situations in a little bit, you have an incredible versatility where there's really not a whole lot, so long as it's over HTTP, that you can't exploit. The other thing that we really focused on with this tool was trying to make it very performant. And if we have time, we're going to talk a little bit about how we did that. But that's something that was pretty key for us. Working with other tools can be pretty time consuming. So having something where you can dump a reasonably sized database in a good amount of time, that's pretty important. Yeah, and did we mention it's fast? One other thing that we want to mention, the folks at Backtrack were kind enough to include this in the latest release, the Backtrack 5R3, so that simplifies the installation process a little bit for people who don't want to mess around with installing libevent and all that stuff. So, like other SQL injection tools, you have to provide a lot of stuff to specify how you want the attack to work. You have to provide the URL, the method, headers, cookies, so on and so forth. Any part of the HTTP request that a browser can send, our tool can send. So you're not going to wind up in a situation where you can't specify the referrer header if you need that. Any part of the HTTP request you can specify. And if you need to do something really funky, the code's pretty easy to hack, so you can add it yourself. In addition to those kind of the boilerplate information, there's a few things that you need to add. And this is where it becomes slightly less than automatic. You need to know where the vulnerability exists. The tool is not going to find that for you. So you need to specify what parameter of the request or what part of the request is vulnerable. The other thing that you're going to need to specify is the SQL syntax that you're going to be injecting into the HTTP requests. So to talk a little bit about that first point, the injection can go anywhere. So if you want to put it in the URL, fine. If you want to put it in the data, the cookie, that's fine. The way that you specify where it goes is with this kind of templating language. So hopefully that's large enough. You see a $sign and then curly brackets. And then that is where the vulnerability is. That's where you're going to be injecting into. And like I said, that can go anywhere in the request. So it can go in the data and the cookies. If you have some really weird edge case and you have SQL injection in the HTTP method, instead of get, you want to have get single tick, blah, 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 you can do that. You can specify any portion of the HTTP request. And that is pretty good for flexibility. That helps you get around, this flexibility helps you get around your weird serialization formats, your weird kind of business logic rules that are kind of preventing these other tools from working normally, weird encodings. The other piece of information that you need to provide, like I said, is the syntax for the SQL injection. And this is somewhat similar, syntactically. You have this scripting language where you specify the different portions of the SQL query that would normally be used for blind SQL injection. So here's kind of a simple blind SQL injection string that you might be inserting. You're going to be selecting data from data. You're going to extract the first character from that. Then you're going to be converting that to an integer, and you're testing the value of that integer for your blind SQL injection. Pretty straightforward. If that's unclear, hopefully it'll become more clear with our demos.
Yeah, what you're seeing here at these, we'll talk in more detail, you're seeing more of the kind of templating language that's been developed. And we'll kind of step through where you want to place the variables and whatnot to help the tool understand where it needs to actually automate part of your tag.
Yep. And the flexibility here is pretty incredible because it doesn't matter if this is some weird SQL syntax that no one has ever heard of, if your client or whatever has developed their own database. This actual syntax for the SQL is totally unimportant to the tool. The same goes for if you have weird character set limitations where you can't put in strings or whatever. It doesn't matter. The other thing is that you can kind of craft clever strings that will help you get around weird IDS, IPS issues if you're trying to be stealthy. We're going to go ahead and give you guys a quick demo and then talk a little bit more about the tool.
All right, so kind of we're going to do just a really basic demo, and we'll do our awesome vulnerable app at nsa.gov. We found this awesome login page that the NSA just must have forgot about. And we're going to go ahead and just log in. You want to scroll just a little bit so you can see the bottom. So you'll see something that say you are auth as user 1. Here are some secrets, right? So we see that when we're logged in, we get a response size that is, of some sort of length. Go ahead and log in with a different. We see now we get bad cred for user 1. So we'll go ahead and jump the gun here and cheat a little bit and say that probably injectable. Go ahead. We're auth as user 1. Great. All right. So we've identified that SQL injection is present. We've noticed that when we have a true or a false statement, the response size is different with the response from the server, right? So that's kind of what we're going to query off of. So here's the process where when you can't get a tool to work, and I've done this by hand so many times, you're kind of starting to build out your query string. You're trying to figure out exactly what it's going to look like. So Ben's kind of built this out. Let's go ahead and try it. Okay, awesome. So that works. So now let's do a false statement so that we can confirm that that query will work. So what he's going to do is flip the comparator so we can determine if we get a false statement, and we do. All right, so at this point we've identified we have a query that works. We know that we can trigger off of the response size of the server. So this is the part where instead of having to go into Python or Ruby and spend all this time whipping up some script, you can kind of plug and paste everything in the BBQ SQL. All right, so scroll out so you can see the cool ads. It's a real thing. So here we go. I can't quite see it, but there's a grill there. It's a Weber.
Are these colors going to work for people, or should I switch to
I would
Increase your font size.
Well, yeah, we're going to do that, but I'm just wondering if there's enough contrast there.
All right, thanks guys. A little freestyle here. Cool. All right. Oh, that's better. Much better. All right. So, it's still black. That's okay. Actually, it looks better. So, what we're going to kind of do is we'll just step through kind of the configuration options, how to work with the tool at a very high level. So, I think that's good. Yeah, it's okay. I just want to make sure you guys can see it, so why don't we go ahead and fire it up and then we'll zoom out a little bit.
Well, all right, this is not good.
Oh, it's cut off?
Yeah.
Okay.
We're professionals, we swear.
We don't have a video, so,
Hopefully we don't mess up too bad.
I think we probably get by with that right now.
Yeah.
Okay. All right. All right, so yeah, so there's definitely more text on the left. Don't let the window fool you.
And there's a prompt at the bottom.
And there's a prompt at the bottom which you cannot, oh, that's gonna be really hard to demo now.
It's okay.
All right, why don't we go ahead and step through the options. So go ahead and hit 1. All right, so basically here's where you can kind of specify all the stuff we were talking about earlier. Files, headers, cookies, value, URL, all that stuff. Basically, you need to provide at least 2 things at a minimum. You need to provide a URL and a method. All the other stuff's optional. So in this particular example, we're not really concerned with session state, so we're just going to go ahead and specify the URL. You'll also see at the end of the URL here, we specified the injection template, and that template's going to let the tool know this is where I'm going to inject the query that we're going to build out in just a second here. Cool.
We're actually better.
All right, there we go. Great. All right, so we've already specified the URL. We know where we're injecting. We've already identified that. So let's go ahead and look at the BBQ SQL options. So you can spit stuff to a CSV output file, especially if you're working with a lot of results. That probably makes sense to specify that. Go ahead and hit technique. We'll brush over this really quickly. We actually built in 2 techniques for searching, doing the blind SQL injection searching. There's a binary search, which is typical, which we see in most of the tools, and we also have a frequency-based search. The frequency-based search can be faster depending on the type of database you're doing, especially with something that's very English-y looking and stuff like that, or programming language-y looking too, because you built the frequency distributions on.
Any text that has a lot of structure to it.
Yeah.
So as long as you're not dumping random data, it's going to give you a little bit of.
Typically, binary search would be fine. So let's just go ahead and use binary for the example here. You guys will see that this the UI looks probably pretty familiar if you ever use a social engineering toolkit. I asked Dave Kennedy if we could I like the UI, so I just wanted to gut it and use it for the tool, so he was totally cool with it. And then we'll go ahead and specify the comparison attribute. So let's go ahead and take a look at that. Step back. Oh, we'll do comparison attribute next. All right, that's
I'm
fine.
sorry.
That's right. We can do query. All right, so comparison attribute, same thing. How are we going to tell the tool what a true and false statement is? What does the tool need to know to determine if it's true or false, right? So here you can specify things like the status code. You know, if it's a true statement and it's a 303 and on a false it's a 404, you can tell the tool to queue off that. Here we know that it's based off of size, as we saw earlier, and I pointed out, so we're going to go ahead and use size as the attribute. Concurrency, this is where we'll juice the tool up a little bit. This basically controls how much concurrency the tool's going to run with. You might have to play with this a little bit. We typically we start with around 30. You can play with it on your own network or when you're attacking a website to see what concurrency works the best. The hooks file we'll come back to, and query. It's kind of documented here, and we'll step through it relatively quickly for time's sake. But you need to supply a few parts or a few template tags to the tool to basically tell BBQ SQL where it needs to automate things. So if we take a look at the query here, we see a row index, for example. This is basically going to say this is where it should iterate rows. And you'll see the syntax that we named the template, and then we put a colon and then a value. The value is basically just a starting value. So we're going to start with 1. I want to start with the first character, right, for example. Character index, same kind of idea, right? We're going to basically tell BBQ SQL what character to select from the query. And we're going to set the first character index to the value 1. We're going to use a comparison operator. So you'll see comparator, and then you'll see a colon and then the greater than sign. So basically going to use that as its comparison operator. Character value, that's what it's comparing the result from. We're going to set that to 0. And then if you're doing a time-based blind SQL injection, you can use the sleep tag there to tell it where to insert the number of seconds of sleep when performing a time-based blind SQL injection attack. So we've already got all the placeholders in place. We've built out the query. Now at this point, we're pretty much ready to run. So what it does at first is a little kind of sanitary, or not sanitary, sanity checking, thank you. And we'll see that the true response has a size of 3661, and we'll see that the false response, which is on the bottom, has a size of 3619. So we're pretty sure that looks like a different size. It looks like the tool's working as it is, so let's go ahead and fire it off. Now here, if there was a problem, you could just hit N and go back and fix your request. All right, so now it's screaming at super high speed. So you'll see in the bottom here, we have some kind of benchmarking stuff. You'll see the number of requests, the number of rows that have been exfiltrated, the working threads, characters, the time, and the characters per second, right? And the request per character. So getting around 10 is pretty good. That tends to be what we average with binary search. Sometimes with frequency search, we can get that down to 8. So we'll go ahead and let it finish dumping the database here.
Wait, why does the NSA have ASCII art in their databases?
Was it everyone?
Good thing that's not a giant badger.
You see it's working pretty quick. It's already made close to 17,000 requests. And if we're not fully out of time here, we can probably step through a little bit of how that works.
You're the last one, so I think keep going.
Keep going.
Okay, cool. Yeah, so this looks a little bit ugly because it's ASCII art, but it's actually incredibly valuable if you're used to working with scripting languages. This is a repr string from Python, so you can just copy and paste this right into another Python script if you need to do some more data processing. So this looks ugly. This does not look like a horse anymore, but it is actually useful. So another feature that we think is pretty awesome is that we brought the hooks from the HTTP API that we're using up to the surface. We're allowing you to trap each and every one of those requests with your own code and modify it however you want. So the way that this works is that you're going to write a little Python script, and you're going to write a method called pre-request or response. And what happens is that the pre-request method gets passed the request object, the HTTP request object, before it gets sent out. And you can do whatever kind of data munging you want. If you need to do some really bizarre stuff to make your exploit work, you can do that here. And then it gets passed along to the application. Same deal with response. If it's not clear based on the size or any of the other comparison attributes that we define in the UI, you can make it work by trapping the response and modifying it however you need to. A few examples that we run into all the time that make this incredibly useful. And just to note, this is another place where a lot of the other tools kind of fail because there's not this flexibility. But we quite frequently, when we're testing an API, see that you need to HMAC send your request. How the hell do you do that with SQLmat? You can't. If you write a simple request hook, you can do that. You can do your own processing of the request. If you're working with an Oracle database, you've probably seen that you need to double URL encode sometimes. You can do that. I haven't seen any other tools that have that flexibility. If you need to do some sort of obfuscation, you're trying to do IDS evasion or whatever, you can provide those kind of features. If you need to inject some sort of side channel information, like let's say you have to put a valid or a recent timestamp in some header, you can inject that yourself. Any other sort of nuances to the application that you're working with, you can make whatever modifications you need with these hooks. And I really feel like that's a pretty valuable feature to this tool. I'm gonna step through real quick a few examples of how this works. So here's the ultimate simple example. You want to log each request that you're sending out to a file. So here's the pre-request method like I was talking about. Right now we're in hooklog.py. So for each request that gets open or that gets sent, we're going to open our log file, we're going to be appending to it, and we're going to write our request URL to that. and then you just return the request. And if we were doing modifications, this could be a modified request that you return. And then the application goes on about its business. It logs each request. Here is a slightly more complicated example, and this is one that we're going to demo for you guys. This is the HMAC signing example that I was talking about, and this is something that we run into somewhat frequently. So here, you get your request object, and this is the, for people who are Python people, this is Kenneth Wright's requests library, which is a very friendly HTTP library for Python. So this request object is fairly standardized and should be fairly easy to work with. So you can extract the URL, we're parsing it. You're going to do an HMAC signature of the query string. Then you're going to inject that query string back into the URL, put the URL back into the request, return the request. And now you have an HMAC signed query string. So I'm going to fire that up real quick. So I'm going to cheat a little bit and just import our config file. And now if we run the tool, you will see this H parameter that we were injecting with the hook. That is an HMAC signature of the query string. And ta-da, it's still there.
Just a couple comments on the UI. It was basically jacked from the social engineering toolkit. Thanks again, Dave. Input validation is performed on each configuration option. This is another problem with a lot of the tools. You're working on command line, and you get all this stuff typed out, and like you realize like you screwed something up with a cookie or whatever. Basically, every time you put in any sort of value in any of the configuration options in the UI, it runs a input validation on to make sure it's formatted correctly. That'll save you a little bit of time. Same thing kind of goes with configuration files. We have basically these config files that have been import and export through the UI or the CLI. And it's pretty easy. Config parsers, it's really easy to use. So let's say like you built out a relatively kind of complicated HTTP request. You can dump that to a config file and work with it in there, for example. So it looks basically like this. You got your request config and your HTTP config. So you can kind of come here and work with it as you need to while you're working on your exploits.
Yeah, we got a few minutes, so I'm going to talk a little bit about how we built this guy. So concurrency is a real bear to work with. For people who've been around a while writing any sort of programs, you've probably done multiprocessing or multi-threading, and that really sucks. It might just be a huge pain in the ass. There's been a lot lately to do with event-driven concurrency, and it makes things way, way easier. I think there's a whole other talk just talking about that, but I'm using G-Event in this tool, which makes doing concurrent networking stuff way, way easy. And then when you pair that with the requests library, which is really awesome HTTP client library, you wind up with G-Request, which is incredibly simple to work with and allows you to do, yes, I have a whole slide on it. So it's either way, really, really easy to work with concurrent HTTP requests. The other thing that we're doing to try to improve our performance here is that we implemented multiple search algorithms, which Scott was talking about a little bit. So when you have your actual blind SQL injection and you're kind of flipping back and forth your greater than and less than sign, trying to determine the value of a single character, you can do a binary search, and that's the pretty obvious way to do it, is to do a binary search for the value of that character, and that's pretty fast. But the other thing that we thought would be interesting would be to try to do a frequency-based search. So if there's a lot of structure to the data that you're trying to exfiltrate, you can kind of exploit that structure. And for example, in the English language, the letter E is the most common, and you can check for that first rather than doing a binary search. You check in order of the frequency. That's fairly straightforward, but you can wind up with a bit of a performance boost. So that's it. We kind of raced through that, given the time constraints. A few credits. You can read that.
Yeah, and thanks. If you guys have any questions, fire them our way.
And we're hiring. And the tools on GitHub or in Backtrack 5 are done. Any questions? We're good.
Thanks, guys.